We're communicating all the time. And when things go smoothly, when a project works out, we just assume it's because we're on the same page. But what if that's not true? What if success has nothing to do with real understanding, especially when we're talking to an AI? Let's dive into this pretty startling idea from some new research.
So, I want to start by asking you something. Just think about it for a second. In your job, with your family, even when you're talking to your smart assistant. To get things done together successfully, do you really need to understand each other? Do you truly have to be on the same page?
Most of us would say, yeah, of course. It just feels right. It's the assumption that pretty much runs our lives. If we nail a presentation or coordinate a family trip perfectly, it must be because we had a shared understanding of what was happening. But we're about to poke some serious holes in that idea.
And look, this isn't just some casual belief we have. It's the main way we judge whether communication is working, especially when we can't just peek inside the mind of the other person or, the AI. We see a good outcome, we see success, and we just figure, yep, understanding must be there.
And this isn't just me talking, this is a real thing in science. Researchers Kondylidis and his team point out that this is a fundamental idea in their field. When agents, human or artificial, work together well, we just take it as proof that they're interpreting the world in the same way. But is that really what's happening?
So to figure this out, the researchers designed this brilliant little experiment. Let's forget about complicated human language for a minute and just imagine a very, very simple game, a game of secret codes played by two AIs.
Okay, so here's how it works. Picture two AI agents, and they're in completely separate soundproof rooms. The first one, let's call it the sender, sees what's going on in its room. Maybe a light is on, maybe it's off, that's the state. Then it sends a secret code, a signal, to the second agent, the receiver. Now the receiver can't see the light, it only sees the code it was sent. Based only on that code, it has to do something, like press button A or button B. And here's the kicker. If it presses the right button for the state of the first room, they both get a point. They never see what the other is doing or seeing, just the code and whether they scored a point or not. So, the goal is super simple. If the room is in state 1, doing action A gets them a point. If it's state 2, action B is the winner. Anything else, and they actually lose a point. They literally have to invent a language from scratch to win. So these agents, they played this game over and over and over again, thousands of times, learning as they went. And what the researchers discovered, well, it's kind of obvious at first. And then it gets really, really weird. Okay, so first, the part that makes total sense. They got good at the game. In fact, they got perfect at it. After they learned the ropes, these two agents hit a 100% coordination rate. Every single time, the sender sent a signal and the receiver took the exact right action. They were crushing it. Success! But here's where it gets wild. The researchers decided to look under the hood. And while the agents were getting the right answer 100% of the time, their true alignment, that is, whether they actually agreed on what the signals meant, was only at 50%. 50%? That's just random chance, a coin flip. And that's the million-dollar question, right? It's a total paradox. How is it even possible to have perfect teamwork, perfect success, with what looks like absolutely zero shared understanding? This seems to fly in the face of everything we think we know about communication. The researchers actually gave this phenomenon a name, and it's perfect, a successful misunderstanding. It's when two partners get the job done, they get the reward, but their internal playbooks for how they did it are completely different. They're both getting the right answer, but for totally opposite reasons. So how on earth does this work? Let's just walk through a quick example. Take a look at the sender's codebook. When it sees state 1, it sends the signal blue. Okay, easy enough. Now follow that signal over to the receiver. It sees blue, and it does action B. But wait a second, remember our reward rules? Action B is the wrong action for state 1. So how do they win? Well, look what happens in state 2. The sender sends red. The receiver sees red and does action A. Again, the correct outcome. Their two codebooks are perfect mirror opposites of each other. The mistakes cancel each other out perfectly every single time. It's two wrongs making a right, creating this flawless but really fragile illusion of understanding. So you might be thinking, who cares? If it works, right? Well, here's the catch. The problem with these successful misunderstandings is that they're incredibly brittle. They only work under the very specific, weird conditions they were born in. So the researchers decided to put that fragility to the test.
To do that, they basically threw a wrench in the works. After the first two agents had perfected their private, totally misaligned language, a new third agent was dropped into the game. This rookie had no idea what was going on and had to learn the system from them.
And what happened? The system immediately fell apart. That perfect 100% success rate, it just plummeted. The group could never really recover either, just kind of hovering around 80%. And why? Because there was no single shared truth for the new agent to learn. The misaligned signals were just too confusing and unstable to bring someone new into the fold. This is why it matters.
Okay, so if a pair of agents can't be trusted to build a solid language, how do you force a system to develop real, genuine shared understanding? Well, the researchers figured that out too.
And the answer is 3. Yep. It turns out the magic number for building a communication system that's actually robust, that's based on shared meaning from the ground up, is 3. Not 2. 3.
The study laid out 2 critical conditions. First, you've got to have at least 3 agents in the group. And second, this part's just as important, everybody has to be able to talk to everybody else. No private little side chats, no isolated pairs. When you have that kind of social pressure from a third party, the system just can't settle on those neat but fragile opposite codes. It forces the entire group to agree on one single shared playbook.
And boy, did it work. When they reran the experiment, starting with 3 agents who could all interact with each other, they didn't just get to 100% coordination. Their internal alignment, their shared understanding, was also nearly perfect. And this time, when they introduced a 4th agent, the system barely flinched. It was strong. It was robust. They had built real shared understanding.
So let's bring this all the way back home. The next time your AI assistant gets your command perfectly right, or a translation app gives you exactly the phrase you needed, it's worth asking yourself, is this real understanding? Or is it a really, really clever, successful misunderstanding? A fragile little pattern that works great right now, but might shatter under the slightest new pressure. This research tells us that success alone is not proof of understanding, and that's something to really keep in mind as we build our future alongside AI.